Morning, ma'am.
Good morning, ma'am.
Morning, come in, come in. How are you?
Fine, ma'am. How are you, ma'am?
I'm fine. Come in. As I am on vacation, I had messaged you to come home for discussion. Hope you had no problem in locating the house.
No, ma'am. It's nice to come to your house.
Yeah,
Oh, that's nice.
first time we are coming.
Oh, that's fine. Come, let's go in. How did you come? By bus or taxi?
So we missed the campus bus, so we walked from hostel to main gate.
Okay.
And then from main gate we took an auto and came to your house. It took almost half an hour from hostel to main gate because it's a 2-kilometer walk, the entire distance. So it took half an hour for us.
What was your speed while walking?
It was 4 kilometer an hour while walking, but the outside distance I don't know, so outside speed I don't know.
How do you say that? You started from your hostel room, from rest,
Yeah.
you picked up speed,
Yeah.
and then you walked along the campus, watching, stopped here and there, watching the deer and the monkeys. Am I right?
Yes, ma'am.
And then finally you took an auto and reached my home.
Yeah.
So, how do you say it is 4 kilometers an hour?
We started from our hostel at 8:30 and reached the main gate at 9 o'clock. So half an hour for covering 2 kilometers.
Okay.
So that's 4 kilometers an hour.
That's why you told me that it is 4 kilometers an hour. Okay, fine. What you have calculated was the average speed. Certainly, you were not moving with the same speed throughout your walk.
Yeah.
Am I right?
Yeah.
So let us take the precise instant, namely 8:45 a.m. during your walk.
Okay.
So what is your instantaneous speed at that time is my question. Is it clear?
Yeah. That I cannot say, but I can definitely say that I was moving with a certain speed at that instant of time.
Okay.
But speed is by definition the ratio of distance covered by the time taken.
Okay.
Now at some point of instant, my distance covered will be 0 and time taken also will be 0 because I am calculating at that instant itself. So it is like 0 by 0, which is an undeterminate form.
See, at the precise instant, exactly at 8:45 a.m., suppose you were walking with speed S0. Now imagine a person moving with constant speed S0, and this person covers a distance of S kilometers in an hour.
Okay.
Then we have S0 is equal to S kilometers per hour. So your instantaneous speed at this particular instant, namely 8:45 a.m., is S kilometers per hour.
Yeah.
Now, how do you calculate the instantaneous speed?
For that, we need a relation between the distance traveled and the time taken.
Yes, you are right. So let us take the distance covered, namely S, in time t, be related by S is equal to f of t.
Okay.
Is that all right? Then our interest is to compute the instantaneous speed at time t equal to t naught.
Yeah.
So what we do is we take an interval from t naught to t naught plus h, where h can be positive or negative. Then we compute f of t naught plus h minus f of t naught divided by h. What does this give?
This is the average speed between the time interval t0 and t0 plus h.
Yes, perfectly correct. Now, this is a reasonably good approximation
Provided
to the actual speed at that time t equal to t naught.
Yeah.
But if h is really very small.
Yes, exactly. So, your S naught is limit as h tending to 0 of f of t naught plus h minus f of t naught divided by h.
Yeah.
So, can you now tell me what is the instantaneous speed at time t equal to t naught?
Yeah. So this expression is nothing but the derivative of f with respect to t at a particular instant t naught.
Yes.
So yeah, we could have directly calculated
Yeah.
the instantaneous speed and told you earlier only.
Oh, this is going to be a very good beginning for today's discussion.
Oh,
So
okay.
let's go in.
Sure.
And then start our discussion.
Okay.
Yes, please. Kuntal and Sushmita, please come in. Sit down.
Yeah.
Yes.
So, ma'am, you are saying that we will discuss about the differentiable function.
Yes, sir. Earlier we had discussed about continuous functions, their properties, and some applications. So from today we shall see what differentiability means and learn about differentiable functions.
Okay.
Fine. Is that right?
Yeah.
Okay.
So I remember we used to find the derivative of a function f, that is df by dt, by using the first principles. So we considered a continuous function f from r to r. If t is changed to t plus delta t in the domain of f, then s is equal to f of t changes from s to s plus delta s, where delta s is nothing but f of t plus delta t minus f of t.
Yes.
As the function f is assumed to be continuous, we see that delta t tends to 0. As delta t tends to 0, the change in s, namely delta s, also tends to 0.
Yes.
Then we have to take the limit as delta t tends to 0 of the quotient delta s by delta t.
Correct. Or in other words, you are taking the limit as delta t tending to 0 of delta s by delta t.
Yes.
So you consider the ratio delta s by delta t when delta t becomes smaller and smaller
Yes.
and approaches 0.
Yes.
So both the numerator and the denominator approach 0 and it is an example of 0 by 0, an indeterminate form.
But we have only learnt that a by b is defined when b is not equal to 0. So I don't understand what is 0 by 0.
Yes, you are right. 0 by 0 is used to denote that it is the limit of the ratio of the numerator divided by the denominator. When both the numerator and the denominator approach 0. It is not the number 0 divided by the number 0.
Okay.
This is just a notation.
Yes, it's just a notation.
Okay.
And 0 by 0 can take any value.
Okay.
And that is why we say that it is an indeterminate. So I shall try to make this clear to you. So what is limit n tending to infinity of 1 by n?
0.
Yeah. So we have limit as n tending to infinity of 1 by n equal to 0.
Yeah.
What is limit n tending to infinity of 2 by n?
That will also be 0.
That is also 0.
Yeah.
So now I shall take the numerator as 0, which is limit as n tending to infinity of 1 by n, and the denominator as 0, which is limit as n tending to infinity of 2 by n.
Okay.
And we shall calculate 0 by 0 in each of these cases.
Okay.
So it is limit as n tending to infinity of 1 by n by 2 by n,
Yeah.
and it is equal to half.
Yeah.
Okay.
Or 0 by 0 can also take the value limit as n tending to infinity of 2 by n by 1 by n, which is equal to 2.
Yeah.
Alright?
So in general I can tell that limit as n tending to infinity k by n by 1 by n, which will be equal to k. So k can be any positive number or negative number.
Yes, you are right.
So 0 by 0 can take the value k, where k is any positive or negative number.
Yes,
Yeah.
you are right.
Even if we take this limit, now limit k by n square, that will also be 0.
Yeah.
Yes.
So I can write limit n tends to infinity k by n by k by n square, and I will get it as infinity,
Yes.
because it will be n and that will go to infinity.
Fine.
Even if I take the limit n tends to infinity minus k by n by k by n square,
Yes, sir.
I will get the value minus infinity.
Yes.
Yeah.
You see that 0 by 0 can take any value between minus infinity and plus infinity.
Yes.
Clear?
Yes, ma'am.
It's clear. So, ma'am, shall we take an example of the function f equal t square
Yes.
and see what happens in that case?
Yes, plot the graph.
I'll plot it. So the graph of the function f of t is equal to t squared will be like this. It is a parabola open upwards.
Yes.
So this is the origin.
Yeah. Take two typical points, t comma t square
Let this point P be t comma t squared
and another point, q,
q
which is t
t plus delta t
Hmm.
comma t plus delta t squared.
Fine. Now compute delta f by delta t.
Yeah. So s is equal to f of t. So we have delta s is equal to f of t plus delta t minus f of t.
Correct.
That is nothing but t plus delta t the whole squared
Yes.
minus t squared, which is t squared plus 2t delta t plus delta t squared
Yes.
minus t squared. So this is nothing but 2t delta t plus delta t whole squared.
Fine.
Yeah.
So as delta t tends to 0, we see that delta s tends to 0.
Yes.
Yes.
So the quotient the limit as t tends to 0 of delta s by delta t is of the form 0 by 0.
Yes. Now take for definiteness t equal to 1 and see what happens.
Okay.
So I shall do it.
Yes.
Point t equal 1,
Yes.
s is equal to f of 1, which is 1.
Yes.
So we are actually at the point 1 comma 1.
Right.
So now delta s by delta t I have to compute as limit delta t going to 0 at the point 1 comma 1.
Yes.
But this will be limit delta t going to 0 2t delta t plus delta t square by delta t. And since delta t is not 0, we can actually divide. So I will get it as limit delta t going to 0 to t plus delta t,
Yes.
and here t is 1. So I will get the value as 2 into 1, and that is 2.
Yes. So you see that in this example, in this case, 0 by 0 takes the value 2.
Yes.
Yes, yes.
Right? So what is happening geometrically here?
So this ratio is nothing but the slope of the chord joining the points p t comma t squared and the point q t plus delta t comma t plus delta t the whole squared.
Yes.
Yeah, and so that is like I have such line, and when this delta t is going to 0, we are actually approaching to a tangent line at that point to that curve.
Yes. So
Namely,
what,
here the point is 1 comma 1.
yes. So what it says is the slope of the tangent to the parabola s is equal to t square at the point t comma t square is limit delta t tending to 0 of delta s by delta t.
Yeah.
Is it clear?
Yes, ma'am.
And in this particular case, the slope of the tangent at 1 comma 1 is given by 2.
Yes,
That's what it means. So shall we take another example of 0 by 0 form?
yeah.
Yes, ma'am.
Yes. What do you
Why-
want to take?
Say sin t.
Yes, try.
Yeah, this function is a continuous function on the entire real line.
Yes,
Yeah.
fine.
So we will do the sin t things.
Okay.
In this case, s is the function f of t given by sin t.
Fine.
So in this case, what will be delta s? That is f of t plus delta t minus f of t,
Yes.
and this is sin t plus delta t minus sin of t.
Fine.
Okay, and it equals to 2 cos t plus delta t plus t by 2 sin t plus delta t minus t by 2.
Yes.
So that is 2 cos t plus delta t by 2
Yes.
sin delta t by 2.
Fine.
Right? Now I have to take the ratio delta s by delta t as delta t going to 0, and this is limit delta t going to 0, 2 cos t plus delta t by 2 sin delta t by 2 by delta t, that can be written as limit delta t going to 0 cos t plus delta t by 2 and sin delta t by 2 by delta t by 2.
Yes.
Now delta t going to 0 and delta t by 2 going to 0 are same, giving the same limiting value. So this part, this limit value will give me 1,
Yes.
and this part will give me cos of t.
Yes.
So I can write it as cos of t.
Yes. Fine.
So in this case, the value, the indeterminate that was 0 by 0 is taking the value cos of t at the point t comma sin t.
So the slope of the tangent to the curve s is equal to sin t at any point t naught comma sin t naught will be cos t naught.
Yes. Right. So can you plot the graph
Yes,
of
ma'am,
this
we can.
function?
Say this is the coordinate axis, and this is 0, this is say pi by 2, and this is pi,
Fine.
and between somewhere it is pi by 4, it is 3 pi by 4. So at the, suppose this is my point 1. So at the 1 pi by 2 it takes the value 1, at 0 it is 0, and pi it is again 0. So the curve will be like this, and it will have this type
Fine.
of function.
So draw the tangent at t is equal to pi by 2.
So t equal pi by 2, it will be like this.
What is the slope?
It should be by theory it will be cos pi by 2 and equals 0. Hence it will be a horizontal line.
Yes. So what is the tangent at t equal to pi by 3?
Okay, pi by 3 will be somewhere here,
What is the slope?
and slope should be cos pi by 3, and that is half.
Yes. So in this example, 0 by 0 takes the values 0 and half.
Yeah.
At these two particular points.
At these particular points, pi by 2, t equal to pi by 2 and t equal to pi by 3.
Yes.
Yes.
Is it clear?
Yes.
So in all these examples, we observe that limit delta t tending to 0 of delta s by delta t denotes the slope of the tangent to the curve s is equal to f of t at some point t comma f of t.
Yeah.
And it is the derivative of the function f with respect to t evaluated at some point t.
Yeah.
Yes.
So following this notation, we can write down what was your instantaneous speed while you were walking.
Yeah.
Yes.
So,
yes, we can write.
It is s evaluated at t equal to 8:45 am.
Yes.
Yes.
Isn't it? So,
It is.
following this notation, we can now write your instantaneous speed while
Yes.
you were walking. You remember we had denoted it by S naught. So, S naught is S evaluated at time t is equal to 8:45 am.
Yes.
So, I shall take my t naught as 8:45 am. So, your instantaneous speed is limit as h tending to 0 of s of t naught plus h minus s of t naught divided by h.
Yes.
And what is this? This is the derivative of s with respect to t evaluated at t equal to t naught, which is 8:45 am.
Yes.
So we now know how to calculate the
Yeah.
instantaneous speed at a particular instant, namely exactly at 8:45 am what was your speed.
Yes, ma'am. We have understood that what is instantaneous speed and what is average speed, and the difference between them also.
Yeah, that's fine. Imagine now a person covering a distance of s kilometers in t hours.
Okay.
So, what is his average speed?
So his average speed should be
S by-
by t kilometer per hour.
Yes, perfectly right. Now I have a question. Should his instantaneous speed at a particular instant be exactly the same as his average speed?
The question is not clear to me, ma'am.
Not clear? Okay, think about the question and have some break. I shall go get some juice and biscuits for you.
Okay. Can you explain what ma'am wanted?
No, I think ma'am, what is looking like whether his average speed will actually be attained at some instant of time. So I think so.
Oh, so you have started discussing.
Yes,
Have
ma'am.
juice.
Oh,
Let us
Thank you,
relax for
Thank you,
some
ma'am.
time.
Yeah.
And then we can continue our discussions. Take some biscuits.
ma'am, I have some understanding. I just want to make it clear whether it is true.
Yes.
So suppose say the man his average speed is 68 kilometer. He covered 68 kilometer in 1 hour. So your question is whether that man will at some instant of time his instantaneous speed was also 68 kilometer per hour or not. Is that the question?
Yeah, you are right, but I shall repeat the question. But before that,
keep it.
let's have juice and then continue with our discussion.
Yes, ma'am.
All right? Okay. So when you met me last time, you told me that you are going to participate in a quiz contest
Yes, ma'am.
organized by a city college.
Yes, ma'am.
So when is it?
It's in the evening, ma'am, today evening. So we thought we'll come here, meet and discuss with you and then leave from here directly for the quiz.
Oh, so you need some time for preparation.
Yes, ma'am.
Yeah, you take this time and prepare for your quiz.
Okay.
I also have got some other work.
Okay.
I'll finish that and come back after some time and then we'll continue our discussion.
Okay.
In the meantime, you prepare for your quiz.
Okay,
But
ma'am.
keep thinking about this question,
Sure, ma'am.
right? It may be one of the questions in your quiz. No one knows.
Yeah.
Yeah, have juice.
Okay,
Yeah.
And then I'll go for my work.
Mm,
Yes.